1.6 Other types of equations. Use factoring to solve the polynomial equation. Okay. So first step is set it equal to 0. Next step, factor it. So the question is, what can we factor out of a 3 and a 75? And the answer is, well, we can factor out a 3. What can we factor out of an x to the fourth and an x to the second? We can factor out x to the second. Then we divide all these by 3x squared, 3x squared. We divide it, and we put the results inside these parentheses. So 3's cancel out on this one. X to the fourth divided by x to the second. 4 minus 2 gives you 2, so we end up with x squared. Now 75 divided by 3 is 25. X to the second divided by x to the second, those cancel out. Set equal to 0. So we keep the 3x squared, and we factor x squared minus 25. So this is difference of squares. Square root of x squared is x. Put that in the first place. Square root of 25 is 5. Put that in the second place of both. We can use this pattern because the middle term is a subtraction, so we're going to have one that's plus and one that is minus. Okay, so now we're done factoring. And now that we're done factoring, the next step is we set the factors equal to 0. So 3x squared equals 0. Divide by 3, divide by 3, cancel, cancel. X is equal to, x squared is equal to 0. Square root, x is equal to 0. Next, x plus 5 equals 0, therefore x is equal to negative 5. And x minus 5 is equal to 0, therefore x is equal to positive 5. So the answer on this one in set notation would be a 0, a negative 5, and a positive 5. Notice that I did not put them in order, but that's okay. This is set notation. Order doesn't matter on this one. Okay, next. What can we factor out of a 4 and a 36? We can factor out a 4. What can we factor out of an x to the fourth and x squared? We can factor out x squared. So we divide both of these by 4x squared. Normally you just do this mentally. You don't actually write this step out. Then we put the result inside the parentheses. And we say 4 is canceled out on this one. X to the fourth divided by x squared. 4 minus 2 is 2. X squared minus 36 divided by 4 is 9. X squared is canceled out, leaving me 9. Next, we factor the difference of squares. Square root of x squared is x. Put that in the first part of both of these parentheses. The square root of 9 is 3. We put that in the second place of both of them. And the middle is a negative, so we follow the pattern of plus, minus. Next, we set all these equal to 0. 4x squared is equal to 0. Divide by 4, cancel, cancel. X squared is equal to 0. Square root. X is equal to 0. X plus 3 equals 0. X is equal to negative 3. X minus 3 is equal to 0. X is equal to positive 3. We put it in the set notation of 0, a negative 3, and a 3. There we go. Example, solve the radical equation. Check all proposed solutions. Okay, now basically, there's a limitation on the domain on this one. We'll go into this in more detail later on, but basically is that whatever's underneath this radical, right, whatever's in there, the radicand, it has to be, in this case, greater than or equal to 0. It can't be less than 0, because if it's negative, you can't take the square root of a negative and have it be a real number. It's going to be imaginary, right? So there's a limitation on the domain in that whatever's underneath this radical sign has to be greater than or equal to 0. You can take the square root of 0 at 0, and you can take the square root of things greater than 0, but you can't take the square root of things less than 0 or negatives, right? It's not going to give you a real answer. But this is how you would find what the actual domain is. You would simply set literally the radicand, the stuff underneath the radical sign, as greater than or equal to 0, and then you would solve this, and that would do it. They don't ask us to find the domain, so I'm not going to do it, but that's the gist of it. So let's do the math. Now, what we want to do is we want to get rid of these radicals so we can get to the stuff underneath it, get to the radicand. And the way we're going to do that is we are going to square it. But whatever you do to one side, you do to the other. That gives me 15 minus 2x is equal to x squared. Now, because we have a 2 there, we're dealing with a quadratic. How do you solve a quadratic? Well, one way of doing that is to set it equal to 0 and use the 0 factor property. So let's assume that's the way we're going to do this. By the way, you could also use the the quadratic equation. Now, sometimes you're going to have to. Like, this may not work. I don't know. I haven't checked. In which case, we'll have to use some other way of doing it, which is okay. But I'm assuming factoring will work on this one. So now we have a simple trinomial, meaning we have one leading coefficient here. So square root of x squared is x. It ends in a negative right here. So we know it's going to have opposite signs, plus, minus. We're looking for two numbers we can multiply together to give you a negative 15, that if you add together would give you a positive 2. Opposite signs, the difference is 2. So it looks like it's going to be a 5 and a 3. Because the middle term is a positive, we know the 5 must be positive and the negative must be 3. Okay, now at this point we're going to set each one of the factors equal to 0, right? So we solved the quadratic by setting quadratic equal to 0, factoring the quadratic, and now setting the factors equal to 0 and solving. Okay, but here's where things get interesting. It may very well be that, and it will be, that one of these answers is not valid. So if I go back and I plug it back in, 15 minus 2x, but instead of x, what if I put in negative 5? Let's see what happens. That gives me 15 plus negative 2 times negative 5 is plus 10, which gives me a 25, right? And the square root of 25 is 5. So we just plug it in. Solve the radicand. Okay. And if we plug the 5 in over here, we'll notice that, well, 5 is equal to 5. 5 is equal to negative 5. And that does not check out. So it turns out that negative 5 is not going to be a valid answer. So again, 5 is not equal to negative 5. When I plug it in on the left side, right, and I do all my work, I get a positive 5. But when I plug it on the right, I get a negative 5. So it doesn't look like that negative 5 is going to be a valid answer. This one right here does not appear to be true. Okay, let's try the 3. Okay, so we say 15 minus 2 times 3, and we set that equal to 3. That's the other side where we plugged it in, right? So now we say 15 minus 6 is equal to 3. We say 15 minus 6 is 9, square root of 9 is equal to 3, and we would say 3 is equal to 3, which actually checks out. Now, the fact of the matter is the power of this equation was initially a 1, and since we increased the power, we add an extraneous answer. So when you increase the power of the equation, you add answers. When you decrease, you can lose answers. So for instance, what we used to do is, for instance, we had x squared and say that's equal to 1. If I just took the square root here and I wasn't careful, I might end up with something like that and I lost an answer, because that could also be negative, right? Positive and negative. So when you decrease the power, you can lose an answer. You got to be careful. When you increase the power, you can also add an extra answer. So you also need to be careful. And that could add an extraneous answer. So it turns out one of these is not going to work. Now, we could have just looked at this negative 5 and found out that's not going to be a valid answer, because a square root is not going to be equal to a negative. So as soon as we started plugging, see that? The square root, this whole entire square root symbol right here, we know that wasn't going to be equal to a negative 5, right? Because the square root of a 0 is 0, and if you try to take the square root of anything less than a 0, a negative, you can't do that. That's not a real number. And if you take a square root of a positive number, obviously it's still going to be bigger than a negative. So if you end up with this square root equal to some negative, that's one of your solutions right here. In this case, the negative 5, you automatically know that's not going to work. So you don't have to plug it all back in and check it. If you don't understand any of that, just plug everything in and check it. It's fine. But there are tricks that you can do so that you can use so you don't have to actually go through all the work of checking everything sometimes. So let's try this one right here. So this one is quite a bit more complicated in that we still have to square both sides to get rid of the radicals. So we're still going to get x plus 7 is equal to, there is a pattern that I want to use for this one, but I just want to point out you don't have to use the pattern if you don't want to. So if I don't use the pattern, it's going to be x times x, which is x squared, x times negative 5, which is negative 5x, negative 5 times x, which is negative 5x, and negative 5 times negative 5, which is positive 25. You're going to combine the two middle ones into x squared minus 10x plus 25, right? Now, this is the pattern, though. If I'm squaring this, I know I'm going to have the first term squared, the last term squared, and I'm going to have 2 times these multiplied together, right? The negative 5 times x is negative 5x, doubled is negative 10x. And that's the pattern. So just looking at this, I know I'm going to have that term squared. At the end, I'm going to have this term squared. And if you say negative 5 times x times 2, we get negative 10x, which is also right. So there is a pattern to that. Hopefully that kind of makes sense. But again, if you don't like the pattern, that's fine. Just rewrite it without the exponents and do it the long way. You'll get the right answer. It's fine. Okay, now this is a quadratic, so let's assume we can factor this. So we're going to try to solve it through the zero factor property. So minus x minus 7 minus x minus 7. So that is going to be 0 is equal to x squared minus 11x, and 25 minus 7 is plus 18. So now we're looking for two numbers that we can multiply together to give you a positive 18 that if you add together give you a negative 11, right? So it's going to be matching because it ends in a positive, matching both negative. And you'll end up with 2 and 9, right? Because 2 times 9 is 18, and negative 2 plus negative 9 is negative 11. So it looks like that way. Yeah. Now at this point, we're going to set each of the individual ones equal to 0 and solve. So that's going to give me x is equal to 2 and x minus 9. You can put them in parentheses or not. And that's going to give you x is equal to 9. So that means your answers are 9 and 2. There you go.